Finally, we have the concept of angle of elevation and angle of depression. If you are looking from the ground up, that is referred to as an angle of elevation. So over here in the picture, notice that we have a swimmer, and the line from, if the swimmer were to look up to the top of this lifeguard tower over here, that looks like a lifeguard tower to me, the angle of elevation is this measurement right here. From the water, where his face is, looking up is the angle of elevation. The angle of depression is formed from the lifeguard and a line parallel to the horizon and looking down. So if the lifeguard's looking straight out and then he suddenly looks down to see the swimmer, from his line of sight to down to the swimmer is the angle of depression. Thinking back to geometry, the angle of elevation and the angle of depression have to be congruent because they are alternate interior angles from parallel lines. So whether you use an angle of depression or angle of elevation, they should both be the same angle anyway. A couple of real-world examples. A golfer is standing at the tee looking up to the green on a hill. If the tee is 36 feet lower than the green and the angle of elevation from the tee to the hole is 12 degrees, find the distance from the tee to the hole. So the distance from the tee to the hole is going to be along the hill up to the elevated green. So I have that marked with an X. So the measurement we do know is the 12-degree angle. The 36 is opposite of that 12-degree angle, and the side we're trying to measure is X. That is a hypotenuse. So that means we're going to use sine. So we will take the sine of 12 degrees and set that equal to the opposite side, which is 36, over the hypotenuse, which is X. You take out your calculator and you find the sine of 12 degrees. So it's not inverse sine, it's just sine. And 4 decimal places, that is about 0.2079. To solve that for X, I'm going to have to multiply both sides by X first, because that'll eliminate the fraction. So that will give me 0.2079X equals 36. And then I would divide by 0.2079, which is what I got when I took the sine of 12. So if you want to be really accurate, you could just take 36 in your calculator and then divide it by the sine of 12 degrees. So you can actually type in the sine of 12. And when you do that, you get about 173.15. It is golf. They don't usually use decimals in golf, so we could just simply say it's 173 degrees. So a short par 3, or excuse me, 173 feet. Still a short par 3 from the tee box to the hole. The last one, a hill of a roller coaster has an angle of descent or an angle of depression of 160 degrees. Its vertical drop is 195 feet. Estimate the length of the hill. You can see that in the picture. The length of the hill is labeled X already. It's right there. So the X is a hypotenuse, and the opposite of 60 is, the 195 is opposite, so that is going to be sine. So we will set the sine of 60 equal to the opposite side of 195 over the hypotenuse, which is X. Again, going back to our special triangles, we know what the sine of 60 is already. Going back to our special triangles, the sine of 60, that's going to be the opposite of the 60-degree angle right here, and that would be the square root of 3. And the hypotenuse is the 2, which is kind of covered up, but you can still see it. So I'm going to replace the square root of 60 with the square root of 3 over 2. Equals 195 over X. Cross multiply, so I get X square root of 3 equals 195 times 2 is 390. Then I will divide by the square root of 3. If I wanted the exact answer, I would have to rationalize the denominator, but the directions do say to estimate the length of the hill. So I will just go to a calculator and take 390 divided by the square root of 3. And when I do that, I get 225.166605. Most coasters are measured in whole units anyway, so rounded to the nearest whole number. The length of that part of the track is 225 feet.